Before the cataclysm, there are whispers, subtle, almost imperceptible shifts in the rhythm of the land that only the most attuned creatures seem to notice. The birds, usually a boisterous choir at dawn, fall eerily silent, their instincts screaming a warning that human senses have yet to register. Small mammals, the burrowers and foragers of the forest floor, abandon their dens and territories, moving with a strange, unified urgency away from a threat they cannot see but can feel deep within their bones. The air itself seems to hold its breath, growing heavy and still, carrying a peculiar metallic tang that hints at the immense chemical changes occurring deep within the Earth's crust. These are the planet's preliminary sighs, the first faint stirrings of a giant awakening from a slumber that may have lasted for centuries or even millennia. Deep below the tranquil surface, a chamber of molten rock, a colossal reservoir of liquid stone and superheated gases known as a magma chamber begins to swell. The pressure inside this subterranean cauldron is building to an almost unimaginable degree, exerting a relentless upward force on the rock above. It is a geological deep breath, a slow, inexorable inhalation of power that subtly deforms the very landscape, pushing the ground upwards by mere centimeters, a change undetectable to the naked eye but a profound signal of the immense forces at play. The water in the local streams and wells may begin to warm, its temperature creeping upwards as the heat from the approaching magma permeates the surrounding rock. Springs that were once cool and clear might now bubble with dissolved gases, their chemistry altered by the volatile compounds seeping up from the depths. These are the telltale signs, the Earth's fever breaking, a clear indication that the boundary between the surface world and the fiery mantle below is growing perilously thin. For the communities living in the shadow of the mountain, these subtle omens are often dismissed as anomalies, curiosities of a landscape they believe they know intimately. But this is a fatal underestimation of the power that lies dormant. The mountain is not a static feature of the landscape, it is a living, breathing entity, a direct conduit to the planet's molten heart. The slight tremors that begin to shake the ground, initially feeling like the distant rumble of a passing train, are not random occurrences. They are the sounds of rock fracturing under immense stress, the straining groans of the Earth's crust, as it struggles to contain the colossal pressure building from within. Each tremor is a countdown, a rhythmic beat in a symphony of destruction that is about to begin its crescendo. The moment of rupture is not always a singular, grand explosion. Often it begins with a sign of weakness, a flaw in the mountain's formidable armor. A fissure, a long crack in the rock, may suddenly appear on the volcano's flank, venting a plume of white steam and gas into the atmosphere. This is the first release of pressure, the safety valve of the planet beginning to give way. The sound is a deafening hiss, a high-pressure jet of superheated water and volcanic gases, including sulfur dioxide and carbon dioxide, escaping their subterranean prison. This initial plume can rise for kilometers into the sky, a stark white pillar against the blue, a beautiful yet terrifying harbinger of the chaos to come. This venting is a critical stage in the eruption's overture. It represents a significant change in the internal dynamics of the volcanic system. The release of gas pressure can have a dramatic effect on the magma still trapped below. As the gases escape, the confining pressure on the molten rock is reduced, allowing more dissolved gases within the magma to expand rapidly, much like opening a shaken bottle of soda. This process, known as exsolution, dramatically increases the buoyancy of the magma, accelerating its ascent towards the surface and making a full-scale eruption increasingly inevitable. The initial fissure is the beginning of a chain reaction. For those witnessing this event from a distance, it is a spectacle of awe-inspiring power. But for anyone closer, the danger is immediate and multifaceted. The vented gases can be toxic, displacing oxygen and creating suffocating conditions in low-lying areas. The ground around the fissure becomes dangerously unstable, prone to collapse as the rock is weakened by heat and pressure. The deafening roar of the escaping steam is a physical assault on the senses, a sound so powerful it can be felt as a vibration deep within one's chest, a constant reminder of the immense energies being unleashed from the earth. And then, the first appearance of the fire within. The white steam may begin to be tinged with grey and black as fragments of solid rock torn from the walls of the conduit are blasted out alongside the gas. This is the start of a phreatic eruption, driven by steam, but it is a clear signal that the magma is now perilously close to the surface. Soon, the incandescent glow of molten rock may become visible deep within the fissure, a hellish red light that illuminates the billowing clouds of steam from within. The giant has not only awoken, it is now clearing its throat, preparing to roar with its full devastating voice. The roar, when it finally comes, is a sound that defies description. It's not merely heard, but felt, a concussive force that resonates through the ground, the air, and, honestly, the very bones of any living creature nearby. The initial rupture gives way to the main event, the Plinian eruption column. With a force equivalent to thousands of atomic bombs, a colossal pillar of ash, gas, and pulverized rock is blasted vertically into the sky. This dark, churning tower of destruction can climb at speeds of over 100 meters per second, punching through the troposphere and reaching high into the stratosphere, sometimes ascending to altitudes of over 30 or 40 kilometers. This eruptive column is a turbulent, self-sustaining engine of chaos. The incredible heat of the ejected material, often over 1,000 degrees Celsius, causes the surrounding air to be rapidly heated and drawn into the column. This convection creates a powerful updraft that helps to propel the ash and gas ever higher, a ferocious thermal current fighting against the pull of gravity. Within this maelstrom, particles of rock and glass collide, generating immense amounts of static electricity. The result is a spectacular and honestly terrifying display of continuous volcanic lightning, with brilliant flashes illuminating the dark, roiling clouds from within. As the column reaches its maximum height in the cold, thin air of the stratosphere, its upward momentum wanes and it begins to spread out horizontally. It forms a vast umbrella-like cloud, a dark canopy of ash that can stretch for hundreds or even thousands of square kilometers. Carried by the high-altitude winds, this cloud begins its grim journey, casting a vast shadow over the earth below. Daylight vanishes beneath this impenetrable shroud, plunging the world into a profound, unnatural darkness. A midday twilight where the only light comes from the fiery spectacle at the eruption's source. From this great cloud, the fallout begins. It starts not as a gentle dusting, but as a heavy rain of abrasive particles. Fine ash, like powdered glass, is accompanied by larger fragments known as lapilli, pebble-sized pieces of pumice and rock, and occasionally much larger volcanic bombs, chunks of molten rock that cool as they fly through the air. This relentless downpour begins to bury the landscape, its weight accumulating on rooftops, causing them to collapse, and smothering forests and fields under a thick grey blanket of sterile stone, silencing the world beneath its suffocating weight. As terrifying as the vertical column of ash may be, there is a far deadlier threat that can emerge from the collapsing fury of an eruption. When the upward thrust of the explosion is no longer sufficient to support the immense weight of the ejected material, or if the eruption column becomes too dense with rock fragments, a portion of it can collapse back upon itself under the force of gravity. This is not a simple fall. It is the birth of a pyroclastic flow, arguably the most destructive phenomenon that a volcano can produce. It is a ground-hugging avalanche of hot gas, ash, and rock fragments that detaches from the main column and surges down the volcano's slopes. This is not a slow-moving landslide of rock. A pyroclastic flow moves with incredible speed, often exceeding 100 kilometers per hour, and sometimes reaching speeds of several hundred. It behaves like a fluid, a dense, turbulent cloud that follows the contours of the landscape, funneling down valleys and riverbeds with terrifying momentum. The temperature inside this incandescent cloud is lethally high, typically ranging from 200 to over 700 degrees Celsius. It's hot enough to incinerate everything in its path instantly. Forests, buildings, and any form of life are vaporized in a fraction of a second. The sheer force of the flow is immense. It carries with it a chaotic mixture of debris, from fine dust-like ash to massive boulders weighing many tons, all suspended within the superheated gas. This deadly combination acts like a liquid battering ram, capable of flattening entire forests and scouring the landscape down to the bedrock. Structures that are not immediately incinerated by the heat are obliterated by the kinetic energy of the surge. There is no defense, no shelter that can withstand the direct onslaught of such a force. Its passage leaves behind a completely transformed world, a sterile, grey desert of ash and pumice. Survival in the path of a pyroclastic flow is impossible. The combination of extreme heat, toxic gases, high-speed impact and total burial ensures complete and instantaneous destruction. It is a force that moves faster than a person can run, hotter than a crematorium, and with the power of a hurricane packed into a ground-hugging cloud of death. For the inhabitants of Pompeii and Herculaneum in 79 AD, this was the agent of their demise, a swift and silent killer that swept down from Vesuvius, freezing a civilization in its final moments and burying it for centuries, a stark testament to the volcano's ultimate power. When the roars of the eruption finally subside and the ground ceases its violent shuddering, a profound and eerie silence descends upon the land. The world that emerges is unrecognizable, a monochromatic landscape sculpted by fire and fury. Everything is covered in a thick uniform blanket of grey ash, which muffles all sound and smothers all life. The vibrant greens of forests and fields are gone, replaced by a sterile alien terrain. Rivers and streams that once flowed with clear water are now choked with sediment, their courses diverted or erased entirely, transformed into thick, muddy torrents of volcanic debris known as lahars, which can continue to pose a threat long after the eruption has ceased. The air remains thick and difficult to breathe for days, sometimes weeks, laden with fine, glassy particles of ash that irritate the lungs and eyes. The sky, once blue, may remain a hazy, brownish orange as the finest dust particles linger in the atmosphere, scattering sunlight and creating surreal, perpetual sunsets. The sun itself is a pale, muted disk, its warmth struggling to penetrate the volcanic haze. The world has been plunged into a volcanic winter, a period of climatic cooling caused by the vast quantities of sulfur dioxide and ash injected into the stratosphere, reflecting sunlight back into space and altering weather patterns on a global scale. For the human survivors who fled the volcano's immediate wrath, the challenges are immense. Their homes, their farms, their entire way of life have been buried or destroyed. The ash contaminates water supplies, destroys crops, and causes machinery to fail. The familiar landmarks that once defined their world are gone. Erased from the map, they are refugees in their own land, faced with the monumental task of rebuilding their lives from the ground up, in a world that has been fundamentally and violently remade. The psychological toll is as heavy as the physical devastation. Yet amidst this scene of utter desolation, the first seeds of a new beginning are already present. The very ash that has brought such widespread destruction is, paradoxically, a source of future life. Rich in minerals like potassium, phosphorus, and other essential nutrients, this volcanic deposit will, over time, break down to create some of the most fertile soils on the planet. The devastation, absolute as it may seem, is not an end, but a violent and profound reset. It is a brutal yet essential part of the Earth's perpetual cycle of destruction and creation. A cycle that ensures that even from the deepest ruin, life will eventually and inevitably return. To comprehend the birth of a volcano, we must embark on a journey deep into the earth, far beneath the solid ground we walk upon. Our planet is not a solid, inert ball of rock. Beneath the thin, brittle crust lies the mantle, a vast layer of silicate rock that extends for nearly 3,000 kilometers towards the Earth's core. While we often think of this layer as solid on geological timescales, it behaves like a very slow-moving, viscous fluid, kind of like thick honey or tar. It is a realm of immense heat and, honestly, unimaginable pressure, where temperatures are so high that rock can soften and flow in vast sluggish currents. These slow convective currents within the mantle are the primary engine of our planet's geology. Hotter, less dense material from deeper within the mantle slowly rises towards the surface, while cooler, denser material from near the crust sinks back down. This perpetual churning motion, occurring over millions of years, drags the rigid tectonic plates of the Earth's crust along with it. It is this fundamental process, this planetary heat engine, that drives continental drift, creates mountain ranges, triggers earthquakes, and ultimately provides the necessary conditions for the formation of volcanoes. The surface world is but a reflection of this deep, hidden turmoil. Within this superheated mantle, under specific conditions, the rock can begin to melt, forming magma. This is not a simple process of just reaching a melting point, since pressure plays a crucial role. In most of the mantle, the immense pressure actually prevents the rock from melting, even at incredibly high temperatures. Instead, melting is typically triggered by one of three main processes: a decrease in pressure, the addition of volatile compounds like water, or an increase in temperature from a mantle plume. It is in these specific zones of melting that the lifeblood of a volcano is created. This molten rock, or magma, is the essential ingredient for volcanism. Being less dense than the solid rock surrounding it, this buoyant liquid begins a slow but inexorable journey upwards. It collects in vast underground reservoirs known as magma chambers, which can exist at various depths within the Earth's crust. These chambers are the staging grounds, the immense pressure cookers where magma accumulates, evolves chemically, and builds pressure over thousands or even millions of years, waiting for a path to the surface to open, a path that will allow it to be born as a volcano. One of the most dramatic and volcanically active settings on our planet occurs where two of Earth's tectonic plates collide. These zones, known as convergent boundaries, are the planet's great recycling centers. Here, a denser oceanic plate is forced to bend and slide beneath a less dense continental plate in a process called subduction. As this oceanic plate descends into the hot mantle, the immense heat and pressure begin to work their transformative magic. This is the primary mechanism that fuels the notorious Ring of Fire, a vast, horseshoe-shaped belt of volcanoes that encircles the Pacific Ocean. The key to magma formation in this setting is water. The subducting oceanic crust is saturated with seawater, trapped within the minerals of the rock. As the plate plunges deeper into the mantle, the increasing temperature and pressure force this water out of the crystalline structures. This superheated water then rises into the overlying mantle wedge. The addition of water, a volatile compound, dramatically lowers the melting point of the mantle rock it permeates, causing it to melt and generate vast quantities of magma. It is a process of flux melting where water acts as a catalyst for creating molten rock. This newly formed magma, being hot and buoyant, begins its ascent. It forces its way through the overlying continental plate, melting and assimilating a portion of the crustal rock as it travels. This journey alters the magma's chemical composition, making it thick, viscous, and rich in silica and dissolved gases. It is this sticky, gas-rich nature that leads to the most explosive and dangerous types of volcanic eruptions. The magma often pools in large chambers within the crust, where it continues to build pressure, waiting for its moment to erupt. Over thousands and millions of years, repeated eruptions from these magma sources build up a chain of towering volcanic mountains on the overriding continental plate, forming what is known as a volcanic arc. Iconic volcanoes like Mount St. Helens in the United States, Mount Fuji in Japan, and the Great Peaks of the Andes in South America are all products of this powerful process of subduction. They stand as majestic yet menacing monuments to the colossal collision of tectonic plates happening continuously, silently, and unstoppably deep beneath the ocean's floor. In stark contrast to the violent collisions of convergent boundaries, there are places on our planet where tectonic plates are actively pulling apart. These are divergent boundaries, the great rift zones where new crust is born. The most extensive of these are found on the ocean floor, forming the vast mid-ocean ridge system, a continuous underwater mountain range that snakes its way for over 65,000 kilometers around the globe. Here, the Earth's crust is being stretched thin, creating a zone of weakness that allows the hot mantle beneath to rise and fill the gap. As the hot mantle rock rises to fill the space created by the separating plates, it experiences a significant decrease in pressure. This process, known as decompression melting, is the primary driver of magma formation at divergent boundaries. The reduction in overlying pressure allows the mantle rock to melt, even without an increase in temperature or the addition of water. This creates enormous quantities of basaltic magma, a type of magma that is relatively fluid and low in dissolved gases. It is the fundamental building block of all oceanic crust. This fluid magma erupts onto the seafloor, not in explosive, towering columns, but in relatively gentle outpourings. It often forms distinctive, rounded shapes known as pillow lavas, as the molten rock is instantly quenched by the cold seawater. Layer upon layer of this newly solidified basalt builds up over millions of years, creating the new oceanic crust that continuously pushes the tectonic plates apart. The entire floor of the world's oceans has been created through this process, a silent, continuous volcanic eruption on a planetary scale, hidden from our view beneath kilometers of water. While most of this volcanic activity occurs deep underwater, in some places, this rifting process happens on land, or the volcanic activity is so intense that it builds up above sea level. Iceland is the most famous example of this, a country that exists only because it sits directly atop the mid-Atlantic ridge. The entire island is a product of this divergent boundary volcanism, a landscape of fissures, shield volcanoes, and vast lava fields. The East African Rift Valley is another example, a place where the African continent is slowly being torn apart, creating a chain of volcanoes and foreshadowing the birth of a new ocean basin in the distant future. Not all volcanoes are born at the turbulent edges of tectonic plates. Some of the most spectacular volcanic features on Earth actually arise in the middle of them, thousands of kilometers from the nearest boundary. These are the result of a different phenomenon, mantle plumes, or as they're often called, hotspots. A hotspot is thought to be a long-lived, exceptionally hot upwelling of rock that originates deep within the Earth's mantle, maybe even from the boundary with the core itself. It acts like a stationary blowtorch, punching its way up through the mantle and burning a hole through the overlying tectonic plate that drifts slowly above it. As the tectonic plate moves over this fixed heat source, the hotspot periodically melts through the crust, creating a volcano. Because the plate is in constant motion, the volcano is eventually carried away from the hotspot's magma source. Cut off from its supply of molten rock, the volcano becomes dormant and eventually extinct, beginning its slow process of erosion. Meanwhile, the hotspot remains in place, ready to burn through a new section of the plate, creating a new active volcano. This process results in a distinct chain of volcanoes, with the oldest and most eroded at one end and the youngest, currently active volcano directly over the hotspot at the other. The Hawaiian Islands are the quintessential example of a hotspot track. The entire archipelago, stretching for over 2,000 kilometers across the Pacific, has been formed by the Pacific Plate, moving northwestward over the Hawaiian hotspot. The oldest, eroded islands and submerged seamounts are found to the northwest, while the youngest and largest island, the Big Island of Hawaii, is currently situated directly over the Mantle plume. It hosts several active volcanoes, including Kilauea, one of the most active in the world. To the southeast, a new submarine volcano, Loihi, is already forming, destined to become the next Hawaiian island in tens of thousands of years. Hotspot volcanism can also occur beneath continents. The Yellowstone caldera in North America is the result of a massive continental hotspot. The North American plate has been slowly drifting over this plume for millions of years, leaving a track of ancient supervolcanic calderas across Idaho's Snake River Plain. Unlike the fluid basaltic lavas of Hawaii, continental hotspots can produce enormous quantities of highly viscous, explosive rhyolitic magma, leading to some of the largest and most catastrophic eruptions in Earth's history, known as super eruptions, which have the power to alter the global climate. Regardless of how the magma is formed, once it reaches the surface, it begins to build the iconic structure we recognize as a volcano. The shape and size of the volcano are determined largely by the properties of the lava it erupts. Fluid, low-viscosity basaltic lavas, like those found at hotspots like Hawaii or divergent boundaries like Iceland, can flow for many kilometers before solidifying. These gentle, effusive eruptions build up broad, gently sloping mountains called shield volcanoes. Their shape resembles a warrior's shield laid flat on the ground, a testament to the far-reaching flows that created them. In contrast, the thick, viscous, gas-rich magmas found at subduction zones produce a very different kind of structure. This sticky lava does not flow far from the vent. Instead, it piles up close to the source, creating steep-sided, conical mountains. These eruptions are often explosive, alternating between flows of thick lava and violent ejections of ash, cinders, and volcanic bombs. This layering of different materials builds up the classic picturesque volcano shape known as a composite volcano or stratovolcano. Mount Fuji, Mount Rainier, and Mount Vesuvius are all prime examples of these beautiful but potentially deadly structures. The anatomy of a volcano is more complex than just its outer cone. At its heart is the conduit, or pipe, a vertical channel through which magma rises from the magma chamber to the surface. At the summit, this conduit opens into a crater, a bowl-shaped depression from which lava, ash, and gas are erupted. Over time, a massive eruption can empty a significant portion of the underlying magma chamber, causing the summit of the volcano to collapse inward, forming a much larger depression known as a caldera. These can be many kilometers in diameter and often fill with water to form crater lakes. Every volcano is a unique geological entity, a pressure valve for the immense heat and energy trapped within our planet. They are the surface expression of a dynamic and restless interior. From the gentle slopes of a shield volcano built by fluid lava flows to the steep, menacing cone of a stratovolcano built by explosive bursts of ash and thick lava. Their form is a direct reflection of their fiery origins. They are not just mountains of rock, they are complex, living systems, direct windows into the powerful and creative forces that have shaped and continue to shape our world. Deep within the Earth's crust, a silent, inexorable process begins. Here in the magma chamber, a vast reservoir of molten rock, the planet's inner heat churns with unimaginable force. This is not a static pool, but a dynamic, seething cauldron where temperatures and pressures are in a constant state of flux. Fresh, volatile magma, rich in dissolved gases like water vapor and carbon dioxide, steadily intrudes from the even deeper mantle below. It's a slow, relentless recharge, adding to the immense potential energy stored just kilometers beneath our feet. Each new influx of material incrementally increases the pressure, pushing against the chamber's rocky confines like a creature testing the limits of its cage. The magma chamber, once a stable system, now begins to swell. The overlying rock, which has held this immense power in check for centuries or even millennia, starts to groan under the strain. Microscopic fractures, invisible to the naked eye, begin to propagate through the solid rock, the first telltale signs of a system approaching its breaking point. This is the Earth's deep, slow breath, a gradual inhalation of power that must eventually be released. The ground above may show no outward signs, but beneath the surface, a colossal geological event is gathering momentum, its timetable dictated by the fundamental physics of heat and pressure. It is a process of immense patience and terrifying potential. This build-up is a delicate yet immensely powerful balancing act. The confining pressure of the solid rock above the magma chamber acts as a natural cork, keeping the dissolved gases trapped within the molten solution. Think of it as a cosmic bottle of champagne buried deep within the Earth, its contents growing ever more volatile. The gases, under such extreme pressure, remain dissolved just as the carbonation in a sealed bottle is invisible. But this equilibrium is fragile. A change in the magma's composition, a sudden injection of new, hotter material, or a weakening of the overlying rock can be the trigger that upsets this delicate and ancient balance. The very chemistry of the magma plays a crucial role in this subterranean drama. Magmas with a higher silica content are more viscous, thicker and stickier, preventing gases from escaping easily. This viscosity acts as a trap, allowing immense pressures to build to truly catastrophic levels. It is in these chambers filled with thick gas-rich magma that the most explosive eruptions are born. The storm is not merely gathering. It is concentrating its power, refining its fury, preparing for a moment when the forces of containment will finally fail, and the planet's fiery heart will be unleashed upon the world above. To comprehend the immense forces at play, one need only look to a simple everyday object, a bottle of carbonated drink. When sealed, the liquid appears placid, the gas within it dissolved and invisible, held in solution by the pressure inside the bottle. The cap, like the rock above a magma chamber, maintains this state of equilibrium. The potential for a dramatic release is there, but it is contained, held in check by a simple mechanical seal. This is the state of a dormant volcano, its immense energy locked away, a sleeping giant awaiting a disturbance to awaken its formidable power. The quiet belies the incredible energy stored within. Now, imagine shaking that bottle vigorously. You are adding energy to the system, agitating the molecules and increasing the internal pressure. The dissolved gas strains against the confines of the bottle, eager to expand. Similarly, tectonic shifts, the slow grinding of the Earth's plates, or the intrusion of new, hotter magma can shake the subterranean chamber. This geological agitation further destabilizes the delicate balance, bringing the system closer to its critical point. The pressure mounts, and the rock cap, the lithostatic pressure, is the only thing preventing a violent, explosive release of this pent-up energy. The moment of truth arrives when the cap is removed. Instantly, the pressure is released and the dissolved gas, the carbon dioxide, can no longer remain in solution. It violently expands, forming a cascade of bubbles that erupt from the liquid in a frothy, chaotic torrent. This is precisely what happens when the rock sealing a magma chamber finally fractures. The sudden dramatic drop in confining pressure allows the dissolved water vapor and other gases to flash into steam, expanding to hundreds, even thousands of times their original volume. This is the engine of the eruption, the force that drives everything. This process, known as exsolution, is the heart of the explosive eruption. It transforms the once sluggish magma into a buoyant, frothing mixture of liquid rock and gas, a substance far less dense than the solid rock surrounding it. This newly energized, frothing magma then surges upwards with incredible speed, blasting through the weakened rock, widening the conduit to the surface. The analogy is complete. The quiet drink has become an unstoppable fountain, and the sleeping giant, its rocky seal broken, has roared to life, driven by the same physical principles that govern a simple bottle of soda. Once the seal is broken, the ascent begins. The magma, now a turbulent gas-powered foam, begins its journey to the surface. It does not flow gently, it blasts its way upwards, a geological cannonball fired from the depths of the Earth. As it rises, the pressure continues to decrease, causing yet more gas to burst out of solution. This creates a powerful feedback loop. The more gas that escapes, the faster the magma rises, and the faster it rises, the more gas escapes. It is a runaway process, an accelerating stampede of fire and rock that becomes more violent with every meter it ascends towards the unsuspecting world above. The path it takes is not a smooth, pre-existing pipe. It is a conduit, a vent that the magma itself carves and widens as it surges upwards. It shatters and melts the surrounding rock, incorporating fragments into its fiery mass. The sound, were we able to hear it from a safe distance, would be a continuous, deafening roar, the sound of a planet breaking apart from the inside. This is not a liquid gently seeping through cracks. It is a violent, explosive excavation driven by pressures that can pulverize solid stone into dust in an instant. The very foundations of the mountain are being torn asunder by the fury ascending through its core. The speed of this ascent is truly breathtaking. In the most explosive eruptions, this frothing mixture of gas and molten rock can travel at several hundred meters per second, approaching the speed of sound. There is no time for the world above to react. The journey from the magma chamber, kilometers below the surface, to the summit can take mere minutes, or in some cases even seconds. This incredible velocity is what gives explosive eruptions their devastating power. It ensures that the energy built up over centuries is released not gradually, but in a single cataclysmic moment. of unimaginable violence. As the magma nears the surface, it often encounters groundwater, which is instantly flashed into steam, adding another layer of explosive force to the already volatile mix. This is a phreatic explosion, a steam-driven blast that can precede the main magmatic eruption, acting as a violent clearing of the throat before the volcano truly roars. The ground swells, trembles, and finally shatters as the head of the magmatic column bursts through the final barrier of rock. The pressure that has been contained for so long is finally released, not into the confining rock, but into the open air of the atmosphere itself. The moment of eruption is a moment of profound transformation. The magma, upon reaching the surface, is instantly renamed. It is now lava, ash, and gas, unleashed from the crushing pressures of the deep. The release into the atmosphere is the climax of the entire process, a spectacle of terrifying beauty and raw, untamable power. A colossal column of ash and gas, known as an eruption column, is blasted high into the sky, sometimes reaching altitudes of over 40 kilometers, piercing the troposphere and even entering the stratosphere. It is a direct, violent connection between the planet's molten interior and the delicate envelope of its atmosphere. This column is not merely smoke, it is a dense, churning mixture of pulverized rock, volcanic glass, and superheated gases. The friction between these particles generates immense amounts of static electricity, resulting in a continuous, spectacular display of volcanic lightning within the dark, roiling cloud. It is a vision of the primordial Earth, a scene of elemental chaos where fire, rock, and electricity combine in a terrifying symphony. The sheer scale is difficult to comprehend. A single large eruption can release energy equivalent to thousands of nuclear bombs, a testament to the power that our planet holds in reserve. The impact on the immediate environment is absolute. Everything in the path of the initial blast is obliterated. Forests are flattened, rivers are vaporized, and the very landscape is scoured clean. But the eruption's influence extends far beyond the volcano's slopes. The colossal ash cloud, driven by high-altitude winds, can travel for thousands of kilometers, blocking out sunlight, disrupting air travel, and blanketing entire continents in a fine layer of gritty dust. The sky turns a foreboding, dusky orange, and day can be turned into an unnatural, suffocating night for those living downwind of the cataclysm. As the eruption column loses its upward momentum, its densest parts can collapse back upon themselves under the influence of gravity. This collapse gives birth to one of the most lethal of all volcanic phenomena, the pyroclastic flow. A searingly hot, fast-moving avalanche of gas, ash, and rock fragments, it hugs the ground, flowing down the volcano's flanks at speeds exceeding 100 kilometers per hour. Temperatures within these flows can reach 1,000 degrees Celsius, incinerating everything in their path. This is the eruption's most destructive weapon, a fiery wave that leaves nothing but sterile, scorched earth in its wake. Once the main explosive phase of the eruption subsides, the volcano enters a new, though not necessarily safer period. The immediate, violent pressure has been released, but the system remains dangerously active. Rivers of incandescent lava, now degassed and less explosive, may begin to flow from the vent or from fissures on the volcano's flanks. These are not the fast-moving pyroclastic flows, but slow, inexorable rivers of fire. They creep across the landscape, consuming all that lies before them, burying homes, roads, and fields under a thick black crust of cooling rock. Their movement is relentless, a deliberate and final reclaiming of the land by the earth itself. The landscape is utterly transformed, a monochrome world of grey ash and black lava. The air, thick with fine dust and the sulfurous tang of volcanic gases, is difficult to breathe. Acid rain, formed when gases like sulfur dioxide mix with atmospheric moisture, can fall for days or weeks, poisoning water sources and stripping the leaves from any surviving vegetation. The familiar world has vanished. replaced by a primeval, alien vista. For the wildlife and human populations that once called this place home, it is a scene of total devastation, a complete and devastating reset of their environment. Yet even in this scene of utter destruction, the seeds of a new beginning are sown. The very ash that has choked the life from the region is, in the long term, a source of incredible fertility. Rich in minerals like potassium, phosphorus, and other trace elements essential for plant growth, this volcanic deposit will, over time, break down to create some of the most productive soils on the planet. The immediate aftermath is one of sterility and death, but the volcano has delivered a paradoxical gift, a promise of future abundance, a foundation upon which life will not only return but thrive with renewed vigor. The eruption, therefore, is not merely an act of destruction, it is a fundamental process of planetary renewal. The lava flows create new land, extending coastlines and building the very ground upon which future ecosystems will be established. The event, so terrifying and final to those who witness it, is, in the grand sweep of geological time, just one more chapter in the Earth's continuous story of creation and recreation. The sleeping giant has awoken, reshaped its domain, and in doing so has laid the groundwork for the inevitable resilient return of life. In the year 79 AD, the Roman Empire was at the zenith of its power, a civilization that believed it had tamed the world. Nestled in the shadow of a seemingly peaceful mountain, the bustling cities of Pompeii and Herculaneum thrived. Their citizens went about their daily lives oblivious to the fact that the mountain they called Vesuvius was not a gentle green giant, but a dormant volcano of immense power. For centuries it had slumbered, its slopes covered in lush vineyards and tranquil forests, giving no hint of the cataclysm that was brewing deep within its core. It was a geological time bomb, ticking silently beside one of the most advanced societies of the ancient world. The first signs were subtle, easily dismissed by a people unfamiliar with the language of a waking volcano. A series of earth tremors shook the region in the days leading up to the eruption, but earthquakes were not uncommon in this part of Italy. Springs and wells dried up, a sign that the ground was heating and deforming, but these were cryptic warnings, their true meaning lost on the populace. Then around midday on that fateful August day, the mountain's peak exploded with a force that defied comprehension, sending a column of ash, pumice and gas soaring miles into the sky, a dark, menacing shape that the historian Pliny the Younger would later describe as resembling an umbrella pine. For hours, the sky rained down a thick blanket of lightweight pumice and ash. In Pompeii, this initial phase was terrifying, but not immediately lethal for all. It piled up in the streets, causing roofs to collapse under the weight, but it gave some a chance to flee. However, the fate of those who remained, and the fate of the neighboring city of Herculaneum, was to be far more horrific. As the eruption column lost its upward energy, it collapsed, unleashing the first of several pyroclastic surges. This superheated avalanche of gas and ash swept down the western flank of Vesuvius, engulfing Herculaneum in an instant. The people of Herculaneum, who had sought refuge in stone boathouses along the shore, believing they were safe, were killed instantly. The intense heat, estimated at over 500 degrees Celsius, vaporized their soft tissues before their skeletons were entombed in the fine ash. In Pompeii, subsequent surges swept through the city, suffocating and baking those who had not escaped. The fine ash preserved their final moments, creating haunting plaster casts of bodies contorted in agony. Vesuvius did not just bury these cities, it created a perfect, terrible snapshot of the last moments of a civilization caught completely unawares by the fury of the earth. Far from the well-documented world of the Roman Empire, on the remote Indonesian island of Sumbawa stood a colossal volcano named Tambora. In April of 1815, after a long period of dormancy, it produced the largest and most powerful volcanic eruption in recorded human history. The initial explosions were heard over 2,000 kilometers away, mistaken by distant colonial officials for the sound of cannon fire. But this was no human conflict. This was an event on a planetary scale, an eruption so vast it would alter the world's climate and plunge communities across the globe into starvation and chaos. The scale of the immediate blast was almost beyond imagination. The eruption column reached an altitude of more than 43 kilometers, ejecting an estimated 160 cubic kilometers of ash and rock into the stratosphere. The island of Sumbawa was plunged into complete darkness for 3 days. Pyroclastic flows raced down the mountain slopes, annihilating every village in their path and wiping out the entire Tamboran culture. The immediate death toll was staggering, with tens of thousands perishing in the initial blasts and the subsequent tsunamis that battered the nearby coastlines. The mountain, which once stood over 4,000 meters high, lost more than a third of its height, collapsing into a massive caldera 6 kilometers wide. But Tambora's deadliest impact was yet to come, and it would be felt across the entire planet. The immense volume of sulfur dioxide blasted into the stratosphere formed a translucent veil of sulfate aerosols, a volcanic shroud that encircled the globe. This veil reflected a significant amount of incoming sunlight back into space, causing a dramatic and sudden drop in global temperatures. The year 1816, the year following the eruption, would become known throughout the Northern Hemisphere as the year without a summer, a direct and devastating consequence of this single geological event on a distant island. The climatic effects were catastrophic. In Europe and North America, summer frosts and ceaseless rains destroyed crops, leading to widespread famine, food riots, and disease. In New England, snow fell in June. In Switzerland, the relentless gloom and cold inspired Mary Shelley to write her Gothic masterpiece, Frankenstein. In China and India, the disruption of the summer monsoon led to crop failures and devastating floods. The eruption of Tambora stands as a chilling reminder that our planet is an interconnected system, where a single, powerful event in one corner of the world can trigger a domino effect of human suffering on a global scale. In 1883, nestled in the Sunda Strait between the islands of Java and Sumatra, the volcanic island of Krakatoa began to stir. For months it sent plumes of steam and ash into the sky, creating a series of dramatic but seemingly localized displays that drew curious onlookers in ships. These were merely the opening acts for a cataclysm that would culminate in one of the most infamous explosions in modern history. On the morning of August 27th, Krakatoa unleashed a sequence of 4 colossal explosions, the third and most powerful of which was an event of almost unbelievable violence. It was a sound that would reverberate around the world. The sound of this final titanic explosion is considered the loudest sound ever recorded in history. It was clearly heard 4,800 kilometers away on the island of Rodriguez near Mauritius, where it was described as the distant roar of heavy guns. The atmospheric shockwave from the blast was so powerful that it traveled around the globe not once but 7 times, registered on barographs as far away as London and Washington, D.C. The explosion completely obliterated 2/3 of the island of Krakatoa, collapsing the volcanic edifice into the sea and sending an estimated 20 cubic kilometers of rock and ash into the atmosphere. The most immediate and deadly consequence of the volcano's collapse was a series of immense tsunamis. Waves, some reaching heights of over 30 meters, slammed into the coastlines of Java and Sumatra with terrifying speed and force. They swept inland for miles, erasing over 165 coastal villages and towns from existence. Entire communities were washed away in moments, and the official death toll, estimated at over 36,000 people, was almost entirely due to these unstoppable walls of water. It was a brutal demonstration of how a volcanic eruption's danger is not confined to its fiery breath alone. For months after the eruption, the world witnessed sunsets of an unearthly, spectacular beauty. The fine volcanic dust scattered in the high atmosphere diffracted sunlight, painting the twilight sky in vivid hues of red, orange, and purple. These eerie, beautiful sunsets, captured in paintings like Edvard Munch's The Scream, were a global reminder of the catastrophe. Krakatoa's roar had faded, but its legacy was written in the sky, a silent, colorful epitaph for the thousands who had perished, and a stark illustration of how a single island's death throe could touch the senses of the entire human race. At the dawn of the 20th century, on the French Caribbean island of Martinique, the city of Saint-Pierre was a thriving commercial and cultural hub, often called the Paris of the West Indies. It sat at the foot of Mount Pelée, a volcano that had been showing increasing signs of activity. Minor eruptions of steam and ash dusted the city, and the local wildlife grew agitated. A mass invasion of ants and centipedes, and a deadly viper infestation in the city streets were all ominous portents of the disaster to come. Yet the colonial governor, concerned about an upcoming election, urged the population to remain calm and stay in the city. This decision would prove to be fatal. On the morning of May 8, 1902, Mount Pelée did not erupt vertically in the manner of Vesuvius or Tambora. Instead, the side of the volcanic dome collapsed, unleashing a horizontal blast, a dense, superheated cloud of volcanic gas, ash and rock. A textbook pyroclastic flow, or nuée ardente, meaning glowing cloud, was expelled directly towards Saint-Pierre. It moved with incredible speed, hugging the ground and racing down the mountainside at over 160 kilometers per hour, a grey, incandescent hurricane of death. The cloud reached the city in less than 2 minutes. Its temperature was estimated to be between 700 and 1,000 degrees Celsius. It was not a force one could hide from. It was an instantaneous, all-consuming wave of incineration. It flattened buildings, flash-boiled the water in the harbor, and killed the city's entire population of nearly 30,000 people in a matter of moments. The deaths were near instantaneous, caused by thermal shock and asphyxiation from the searingly hot gas and ash. The Paris of the West Indies was transformed into a silent, smoldering ruin. In the aftermath, a horrifying scene of utter devastation was revealed. The city was a monochrome landscape of rubble and ash, with the charred remains of its inhabitants frozen in their last desperate moments. Miraculously, there were 2 known survivors. One was a man named Louis-Auguste Siparis, a prisoner who was saved by the thick stone walls of his partially underground solitary confinement cell. His story, and the complete annihilation of Saint-Pierre, served as a terrifying lesson for the burgeoning science of volcanology. It highlighted the unique and devastating threat of the pyroclastic flow, the deadliest weapon in a volcano's arsenal. Each of these cataclysms, separated by centuries and continents, tells a unique story of destruction. Yet, together they form a powerful narrative, a series of crucial lessons etched in the volcanic ash of history. The tragedy of Pompeii taught us about the sudden, overwhelming nature of pyroclastic surges and the importance of heeding the earliest, most subtle warnings from a restless mountain. It revealed that a seemingly peaceful green landscape can hide a terrible secret, and that civilizations, no matter how advanced, are never truly immune to the raw power of the natural world. Its preservation offered a unique, if grim, window into the past. Tambora's global winter was a lesson on a far grander scale. It demonstrated for the first time in the scientific era that a single volcanic eruption could have profound and lasting impacts on the entire planet's climate system. It showed that the Earth is a deeply interconnected web, where an event in a remote corner of Indonesia could lead to famine in Europe and failed monsoons in Asia. This eruption was a wake-up call, forcing us to recognize the volcano not just as a local hazard, but as a global force capable of shaping human history through its influence on the very air we breathe and the weather that governs our food supply. Krakatoa's deadly roar underscored the immense danger of tsunamis generated by volcanic collapse. While the explosion was a spectacle of sound and fury, the true killer was the silent wall of water that followed. It proved that for coastal communities living near volcanic islands, the greatest threat may come not from the sky, but from the sea. The event, happening in an age of telegraphs and global shipping, brought the reality of volcanic hazards into the homes of people around the world, making it one of the first truly global news events and cementing the volcano's place in the public imagination as a symbol of untamable power. Finally, the horror of Mount Pelée and the annihilation of Saint-Pierre provided volcanology with its most terrifying case study, the Nuée Ardente. It was a stark lesson in the specific lethal mechanics of the pyroclastic flow, a phenomenon that kills with a speed and thermal intensity that makes escape virtually impossible. The political failures that compounded the disaster also served as a grim reminder of the human responsibility in mitigating such risks. Together, these four horsemen of the volcanic apocalypse have shaped our understanding, fueled our scientific inquiry, and stand as permanent solemn warnings of the sleeping giants that lie beneath our feet. We have journeyed deep into the Earth's fiery heart, witnessed the terrifying mechanics of an eruption, and walked through the ash-covered ruins of history's most devastating volcanic events. We've seen how these colossal forces of nature can reshape our world in a matter of moments, leaving behind legacies of both destruction and creation. The stories of Vesuvius, Tambora, Krakatoa, and Pelée are not just historical footnotes. They are profound and humbling reminders of the immense power that churns silently beneath the surface of our planet, a power that commands our respect and our understanding. These events, though separated by vast gulfs of time and space, are connected by a single fundamental truth. Our world is alive. It's a dynamic, ever-changing sphere, not a static stage for human activity. The ground beneath our feet is not as solid and dependable as it may seem. It's the thin, fragile crust of a molten world, a world that occasionally needs to release its internal pressure. Understanding this is the first step towards appreciating the delicate balance in which our own existence is poised. It's a perspective that fosters a deeper connection to the planet we call home. The study of these giants is more than just a scientific endeavor. It is a crucial part of our ongoing story of survival and adaptation. By learning from the tragedies of the past, we equip ourselves to protect the communities of the present and the future. Every piece of data gathered from a seismometer, every gas sample collected from a fumarole, and every satellite image of a swelling volcanic dome adds to a growing body of knowledge that can save lives. This quest for understanding is a testament to human resilience and our innate drive to make sense of the world around us. And so, we stand at a crossroads in our journey. We've looked back at the destructive power of these natural wonders, but the story is far from over. The same forces that have unleashed such devastation are also responsible for some of the most vital and life-giving processes on our planet. The narrative of the volcano is a dual one, a tale of both fire and fertility, of endings and new beginnings. Before we explore the life-affirming side of this story, we want to ensure you are with us for the entire expedition. The path we have trodden so far has been one of awe and trepidation, exploring the immense destructive capabilities of volcanoes. But the journey ahead promises a different perspective. We're about to pivot from the shadows of destruction into the light of creation. We will investigate how these same fiery mountains are, paradoxically, architects of life. We will uncover how the very ash that smothers cities can, over time, give rise to the most fertile soils on Earth, creating agricultural paradises that have sustained civilizations for millennia. This is the other face of the volcano, a nurturing aspect often overlooked. Our exploration will not stop there. We will journey to the newest land on our planet, places born from the sea in a maelstrom of steam and lava, and witness how life takes its first tenacious hold on these sterile volcanic canvases. From the smallest microbe to the most vibrant forest, we will see how nature reclaims and colonizes these freshly forged landscapes. We will also dive into the heart of modern innovation, discovering how humanity is learning to harness the volcano's immense inner heat, tapping into geothermal energy as a clean, sustainable power source for our future. And then, our adventure will take a suspenseful turn as we look towards what lies ahead. We will confront the concept of supervolcanoes, continent-altering behemoths, whose eruption could trigger a new volcanic winter and pose a threat to our global civilization. We will dive deep beneath the waves to explore the hidden world of underwater volcanoes, vast ranges, and individual giants whose activity can reshape the ocean floor and trigger tsunamis with little to no warning. The future holds threats as immense as any we've seen in the past. This is not just a collection of facts, it is an ongoing narrative about our planet and our place within it. From the life-giving soils to the existential threat of a super eruption, the story of the volcano is the story of Earth itself. It's a story of risk, resilience, and renewal. We are committed to bringing you every chapter of this incredible saga, to explore every facet of these magnificent and terrifying natural wonders. To ensure you don't miss a single moment of this unfolding drama, we invite you to become a permanent part of our expedition team. If the journey so far has captured your imagination, if the power and majesty of these geological titans have left you in awe, then we extend a direct and heartfelt invitation to you. This exploration is far from complete, and the most fascinating discoveries may still lie ahead. By subscribing to this channel, you are not just clicking a button, you are securing your front row seat for the remainder of this epic voyage, and for all the incredible journeys we have planned for the future. It is your passport to a world of discovery, delivered directly to you. Every single subscription is a powerful signal of support. It tells us that you value this kind of deep, immersive storytelling. It tells us that you share our passion for understanding the natural world in all its terrifying beauty and complex wonder. Your support is the fuel that allows us to continue these expeditions, to spend the time researching, scripting, and producing the content that takes you from the heart of a raging volcano to the deepest trenches of the ocean. It empowers us to keep asking big questions and to share the answers with all of you. Don't let the algorithm decide what you see next. Take control of your journey of discovery by hitting that subscribe button right now. When you do, you ensure that you will be the first to know when the next chapter of our volcanic saga is released. You won't miss our exploration of life-giving lava fields, our deep dive into the threat of supervolcanoes, or our essential guide to surviving in the shadow of these giants. Subscribing is the single best way to stay connected and to continue learning with us. And while you are there, consider ringing that notification bell. In a world of endless content, that small bell is your personal guarantee that you won't miss a thing. It's a small action that makes a huge difference, ensuring that our next adventure lands directly in your feed the moment it goes live. So please take this moment, hit subscribe, ring the bell, and join our growing community of explorers, thinkers, and lifelong learners. We're incredibly grateful for your viewership and your support. This channel is more than just a series of videos. It is a community, a gathering place for everyone who is fascinated by the power and complexity of our planet. Your voice, your thoughts, and your questions are a vital part of this community. The comment section below is not just a space for feedback, it is our digital campfire where we can all share in the awe and wonder of these natural phenomena. We read your comments, and your insights often shape the direction of our future content. So we ask you, what has been the most mind-blowing fact you've learned so far? Was it the sheer scale of the Tambora eruption and its global winter? Was it the haunting story of the plaster casts of Pompeii preserving a moment in time? Or was it the incredible speed of a pyroclastic flow, a force of nature that moves faster than a hurricane? Share your thoughts with us and with your fellow viewers. Let us know what part of this journey has impacted you the most. Perhaps you have your own experiences with volcanoes. Have you ever visited one? Have you seen the fertile fields on its slopes or hiked across the stark beauty of an old lava flow? Do you live in a region shaped by volcanic activity? Your personal stories and perspectives enrich this conversation for everyone, transforming it from a one-way broadcast into a shared exploration. We encourage you to share your experiences and connect with others who have felt the presence of these sleeping giants. Your engagement helps build a more vibrant and knowledgeable community. By liking this video, you tell the wider world that this is a story worth watching. By sharing it with a friend, a family member, or on your social media, you help spread this knowledge and passion to new audiences. Every like, every comment, and every share helps this community grow and allows us to continue bringing these incredible stories of our planet to life. Let the conversation begin. Thank you for taking this moment with us. Your support truly means the world and allows us to continue this mission. we promise that the rest of our journey together will be just as dramatic, informative, and visually stunning as what you have seen so far. We are about to delve into the incredible duality of volcanoes, exploring how these agents of destruction are also fundamental creators of life and landscape. The story is about to take a turn towards hope, resilience, and the remarkable adaptability of life on Earth, so stay tuned. Do not go anywhere. The next chapter is coming right up, where we will witness firsthand how the destructive force of an eruption lays the foundation for lush, vibrant ecosystems. We will see how humanity has learned to live not just in fear of volcanoes, but in partnership with them, drawing sustenance and energy from their immense power. It is a side of the story that is absolutely essential to understanding their true role on our planet. The narrative of fire and brimstone is about to become a story of soil and survival. We are incredibly excited to share it with you. The team has worked tirelessly to bring these concepts to life, to transport you to these incredible locations, and to tell the full, complex story of the volcano. Your decision to subscribe and stay with us makes all that effort worthwhile. You are the reason we do this, and we are committed to honoring your curiosity with content that both educates and inspires. The greatest chapters are still to come, and we are thrilled to have you with us. Now, prepare yourself. Our exploration is about to continue. We will rise from the ashes of Pompeii and Krakatoa and ascend the fertile slopes of mountains that give life back to the world. The sleeping giants have shown us their fury, and now they will reveal their generosity. Let's dive back in as we explore how volcanoes, the architects of destruction, are also the essential sculptors of life itself. The adventure is far from over. From the searing heart of destruction, paradoxically, springs the very essence of life itself. A volcanic eruption in all its terrifying majesty is not merely an end, it is a profound and violent beginning. The immediate aftermath paints a picture of utter desolation, a monochromatic landscape smothered under a thick blanket of grey ash, seemingly devoid of all vitality. It appears as though nature has been silenced, the vibrant chorus of life extinguished by the Earth's fiery breath. But this is a temporary state, a mere pause in the planet's relentless cycle of renewal. Beneath this sterile shroud, the seeds of a new world are waiting for their moment to emerge into the light. This very ash, the fine silken dust that chokes the air and buries the land, is a gift from the deep earth. It is a treasure trove of minerals, a concentrated delivery of the fundamental building blocks required for life to flourish. Unlike the tired, weathered soils that have been leached of their nutrients over millennia, this volcanic deposit is fresh and potent. It contains phosphorus, potassium, calcium, magnesium, and a host of trace elements, all essential for plant growth. This is not just dirt, it is a potent primordial fertilizer delivered on an epic scale, promising a future of unparalleled abundance where before there was only barren rock or depleted earth. The process of transformation is not instantaneous. First, the rains must come, washing the finer particles into the soil and beginning the slow, patient work of chemical breakdown. Hardy pioneer species, lichens and mosses, are often the first to colonize this new alien terrain. Their tenacious grip breaks down the rock, their life and death cycles adding the first precious organic matter to the nascent soil. They are the vanguard of a biological invasion, the first architects of a new ecosystem, preparing the ground for the more complex life that will inevitably follow them, drawn by the promise of this rich new foundation. And so the grey canvas begins to bloom. Over years and decades, what was once a scene of apocalyptic ruin transforms into a flourishing paradise. Ferns unfurl their delicate fronds and grasses push their way upwards, their roots anchoring the new soil. Soon shrubs and then trees take hold, their growth spurred on by the mineral wealth locked within the volcanic layers. The land, once sterilized by fire, becomes a testament to resilience, a vibrant green tapestry woven from the very ashes of its own destruction, demonstrating nature's incredible power to regenerate and create abundance from chaos. Volcanoes are not only architects of soil, they are architects of the land itself. With every eruption, they engage in a colossal act of planetary construction, adding new territory to our world. When a submarine volcano breaches the ocean's surface, or when lava flows from a coastal vent and meets the sea, something truly magical occurs. The molten rock at over 1,000 degrees Celsius collides with the cool ocean water in a dramatic explosion of steam and sound. It's like a battle between fire and water, from which the land emerges victorious, solidifying into new black rock, extending the coastline inch by painstaking inch. This process, repeated over countless millennia, is responsible for the very existence of some of the most beautiful and iconic island chains on our planet. The Hawaiian archipelago, a string of emerald jewels set in the vast blue of the Pacific, owes its being entirely to a single volcanic hotspot in the Earth's mantle. Each island is a colossal mountain, its true scale hidden beneath the waves, built layer by layer from successive lava flows. From the seafloor to the summit, they are monuments to the patient, creative power of volcanic activity, a testament to how the planet continually reshapes its own face from the inside out. The birth of a new island like Surtsey off the coast of Iceland in the 1960s provides a rare and precious opportunity for science. It is a natural laboratory, a blank slate upon which the story of life can be observed from its very first chapter. Scientists watched in awe as the first seeds, carried by ocean currents or the wind, found purchase on the sterile rock. Insects and then birds arrived, bringing with them the potential for more complex colonization. Observing this process in real time offers unparalleled insights into how life takes hold and how ecosystems establish themselves from absolutely nothing, a process that has happened countless times across Earth's history. This creation of new land is not merely a geological curiosity, it has profound implications for life. It provides new habitats, new ground for species to colonize, driving evolution and increasing biodiversity. For humanity, it has meant new territories to settle, new shores to explore. The very ground beneath the feet of millions is a direct gift from the planet's molten heart. These volcanic lands, born of fire and steam, demonstrate that the same forces that can bring about sudden and dramatic destruction are also the planet's primary agents of creation, constantly renewing and expanding the stage upon which life can play out its drama. Deep beneath the surface, the same heat that fuels a volcano's destructive fury can be harnessed as a powerful and remarkably clean source of energy. This is the realm of geothermal power, a direct line to the immense thermal reservoir of our planet's core. In volcanically active regions, the Earth's magma lies much closer to the surface, heating vast, underground aquifers of water to tremendous temperatures. This superheated water and steam becomes a potent, accessible energy source, a natural boiler system created by the planet's own internal engine, waiting to be tapped by human ingenuity. The process is, in principle, elegantly simple. Wells are drilled deep into these geothermal reservoirs, sometimes several kilometers down, to reach the pressurized, superheated steam. This steam is then channeled to the surface under its own immense pressure and used to spin turbines, which in turn drive generators to produce electricity. It's really a way of capturing the raw primal heat of the Earth and converting it into the power that lights our homes and runs our cities. Unlike fossil fuels, the source is virtually inexhaustible, drawing upon the near limitless heat of the planet's formation. Countries situated along tectonic plate boundaries like Iceland, the Philippines and New Zealand have become pioneers in this field, turning their geological volatility into a national asset. Iceland, a land famously forged by fire and ice, now derives a significant portion of its electricity and nearly all of its heating from geothermal sources. Hot water is piped directly from the ground into homes and businesses, and even used to heat greenhouses for growing food in the subarctic climate. It is a harmonious way of living with the land, transforming a potential threat into a source of sustainable prosperity and energy independence. The benefits of geothermal energy extend far beyond its reliability. It is a remarkably clean power source, releasing minimal greenhouse gases compared to the burning of coal, oil, or natural gas. The land footprint of a geothermal plant is also significantly smaller than that of solar or wind farms of equivalent output. By harnessing the very heat of their volcanoes, we find a path towards a more sustainable future, a way to power our civilization that works in concert with the planet's natural processes rather than against them. The sleeping giants beneath our feet offer not just a warning, but also a promise of clean, abundant energy. The influence of volcanoes extends far beyond the ground we walk on. They are powerful sculptors of the very air we breathe and the climate we experience. During a major eruption, volcanoes release vast quantities of gases into the atmosphere, most notably water vapor and carbon dioxide. Over geological timescales, this process of outgassing has been fundamental to the creation of Earth's atmosphere and oceans. The air and water that make our planet a unique haven for life were, in large part, carried from the planet's interior and released through countless volcanic vents over billions of years. While carbon dioxide warms the planet, other volcanic emissions can have a potent, albeit temporary, cooling effect. The most significant of these is sulfur dioxide. When injected high into the stratosphere, far above the clouds, this gas reacts with water vapor to form a fine mist of sulfuric acid droplets. This aerosol layer acts like a vast, hazy mirror, reflecting a portion of the incoming sunlight back into space before it can warm the Earth's surface. A single, powerful eruption can create a global veil that lowers average planetary temperatures for several years. The eruption of Mount Pinatubo in the Philippines in 1991 was a dramatic modern example of this phenomenon. It injected roughly 20 million tons of sulfur dioxide into the stratosphere, creating a global aerosol layer that caused average world temperatures to drop by about half a degree Celsius for the following 2 years. This event provided scientists with a real-world experiment, confirming climate models and demonstrating the profound sensitivity of our planet's climate system to atmospheric composition. It was a stark reminder of how a single geological event can have far-reaching and global consequences for every living thing. This duality, the release of warming greenhouse gases over the long term and cooling aerosols in the short term, reveals the complex and critical role volcanoes play in regulating Earth's climate. They are a key part of a global thermostat, their activity influencing the delicate energy balance that determines whether the planet cools into an ice age or warms into a hothouse. Understanding this intricate dance between geology and atmosphere is crucial, as it underscores the interconnectedness of all Earth's systems and the powerful planetary scale forces that have shaped and continue to shape the world we inhabit. In the deepest, darkest corners of our oceans, far from the life-giving light of the sun, exists a world that was once thought to be an utter wasteland. Here, in the crushing pressure and perpetual night of the abyssal plain, volcanic activity creates astonishing oases of life. These are hydrothermal vents, often called black smokers, which are fissures in the ocean floor, typically along mid-ocean ridges where tectonic plates are pulling apart. Seawater seeps into the cracks, is superheated by underlying magma, and then erupts back into the ocean as a scalding, mineral-rich plume. This plume, which looks like black smoke, is not smoke at all, but a dense soup of dissolved minerals like sulfur, iron, zinc and copper, precipitating instantly as they hit the near-freezing seawater. Around these seemingly toxic undersea geysers, a vibrant and bizarre ecosystem thrives, one that completely rewrites the rules of life. Instead of photosynthesis, which relies on sunlight, the foundation of this food web is chemosynthesis. Specialized bacteria harness the chemical energy from the sulfur compounds spewing from the vents, creating organic matter in a process that is pure alchemy. These chemosynthetic bacteria form the base of a unique food chain supporting a menagerie of creatures found nowhere else on Earth. Giant tube worms, some over 2 meters long, with bright red plumes and no mouth or gut, live in a symbiotic relationship with the bacteria housed inside their bodies. Ghostly white crabs scuttle across the mineral chimneys, and strange fish and octopuses patrol the periphery of this otherworldly garden. It is a self-contained world powered not by the sun but by the geothermal heat of the planet's own core, a direct link between geology and biology. The discovery of these hydrothermal vent communities was one of the most profound biological finds of the 20th century. It suggested that life might not be solely dependent on sunlight and could potentially exist in other seemingly inhospitable environments, both on Earth and perhaps on other worlds in our solar system, like the icy moons of Jupiter and Saturn. These deep-sea volcanoes, therefore, do more than just create new crust. They support entire ecosystems in the dark, expanding our understanding of life's tenacity and revealing that even in the most extreme environments, the creative spark of the planet can foster worlds of incredible wonder. Here in the vast, seemingly tranquil landscapes of our planet lie secrets of immense power, dormant for now, but holding the potential for cataclysm on a scale almost beyond our comprehension. We speak of supervolcanoes. These are not the conical mountains we typically imagine, rather they are colossal depressions in the Earth's crust, known as calderas, formed by eruptions so vast they cause the very ground to collapse inwards. Beneath these serene surfaces, magma chambers of unimaginable size slowly churn, accumulating pressure over millennia, patiently waiting for the moment when the planet itself must exhale with a force that can reshape continents and alter the course of life itself. The scale of such a magma chamber is difficult to grasp. Imagine a subterranean lake of molten rock stretching for dozens, sometimes hundreds of kilometers across and several kilometers deep, a seething cauldron of heat and dissolved gases. The Yellowstone caldera in North America, for instance, sits atop a magma reservoir so immense it could fill the Grand Canyon more than 11 times over. This is not merely a geological feature, it is a living, breathing system, a planetary organ whose slow rhythmic pulse is measured in the rise and fall of the ground above, in the steaming geysers and in the tremors that ripple through the ancient rock. These giants do not awaken often. Their eruptive cycles are measured not in centuries but in hundreds of thousands or even millions of years. Yet this great passage of time is precisely what allows them to accumulate such terrifying potential. Each passing millennium adds more molten rock, more volatile gas to the chamber below, stretching the crust above to its absolute limit. The signs of an impending eruption would be subtle at first, a slight increase in ground deformation, a change in the chemical composition of gases venting from fumaroles, but they would be the harbingers of a truly global event. A geological final warning. We stand upon the shoulders of these sleeping giants, often unaware of the power that stirs beneath our feet. The study of these supervolcanoes is a journey into the deep time of our planet, a reminder that the forces that forged our world are still very much active. Understanding their behavior, deciphering their subtle language of tremors and vapors is not merely an academic pursuit, it is a vital necessity. For when one of these titans finally stirs from its long slumber, its awakening will be felt not by a single region but by all of humanity, a stark reminder of our place on this dynamic and ever-changing Earth. The eruption of a supervolcano would be an event unlike any witnessed in human history. It would not be a localized disaster but a planetary transformation. The initial explosion would eject trillions of tons of ash, rock and sulfur dioxide into the atmosphere, a colossal column of debris punching through the troposphere and deep into the stratosphere. This dense, dark cloud would not dissipate quickly. Instead, it would be carried by high-altitude winds, spreading like a funeral shroud across the entire globe within a matter of weeks, blanketing the sky from pole to pole in a persistent sun-blocking haze. This atmospheric veil would trigger a phenomenon known as a volcanic winter. With sunlight unable to reach the Earth's surface, global temperatures would plummet dramatically, by as much as 5 to 10 degrees Celsius. This sudden and prolonged plunge into cold would be catastrophic for life. Growing seasons would fail worldwide, leading to the collapse of agriculture on an unprecedented scale. The intricate web of our global food supply, so dependent on predictable climates and stable harvests, would be torn asunder, threatening famine for billions and igniting conflicts over dwindling resources across the world. The ecological consequences would be equally devastating. Forests would wither in the dim light and freezing temperatures, grasslands would turn to barren wastes, and the delicate balance of ecosystems would be shattered. Marine life, too, would suffer immensely. The vast quantities of sulfur dioxide blasted into the atmosphere would mix with water vapor to form sulfuric acid, falling back to Earth as acid rain. This would poison soils and fresh water sources, and most critically lead to the acidification of the oceans, dissolving the shells of plankton that form the very base of the marine food web. This is not speculation drawn from fiction. It is a future foretold by the past. Geologists studying ancient rock layers have found evidence of such events, like the Toba eruption some 74,000 years ago, which some scientists believe pushed early humanity to the very brink of extinction. A super eruption today, in our densely populated and interconnected world, would present a challenge of an entirely different magnitude. It would be a test of our resilience, our ingenuity, and our ability to cooperate in the face of a crisis that threatens the very foundations of civilization as we know it. While our gaze is often drawn to the fiery mountains on land, an immense and largely hidden volcanic world exists beneath the waves. More than 70% of all volcanic activity on Earth occurs on the ocean floor, along vast mid-ocean ridges where tectonic plates pull apart. Here, in the crushing pressure and perpetual darkness of the deep, a continuous slow-motion eruption builds new crust, shaping the very floor of the sea. These submarine volcanoes are the architects of our planet, the unseen engines driving the slow dance of the continents across the globe. But not all underwater volcanism is so gentle. Just as on land, violent, explosive eruptions can and do occur in the ocean's depths. When a submarine volcano erupts with sufficient force in shallower waters, the consequences can be immediate and honestly terrifying. The explosive release of gas and magma can displace colossal volumes of water, generating tsunamis of immense power. These waves can travel across entire ocean basins at the speed of a jetliner, arriving at distant coastlines with little warning, as devastating walls of water capable of obliterating coastal communities and reshaping shorelines in an instant. The 1883 eruption of Krakatoa, an island volcano, provided a chilling example of this power, generating tsunamis that killed tens of thousands. But the threat also lies with volcanoes that are entirely submerged. The potential collapse of a volcanic flank, a massive underwater landslide triggered by an eruption or seismic activity, could displace even more water than a direct explosion. Scientists are closely monitoring several such ticking time bombs, like the Cumbre Vieja volcano in the Canary Islands, where a future collapse could send a mega tsunami racing across the Atlantic, threatening coastlines in the Americas, Europe, and Africa. The deep ocean conceals these threats from our daily view, but it cannot hide them from our scientific instruments. Through sonar mapping, submersible exploration, and seismic monitoring, we are slowly piecing together a picture of this volatile underwater realm. Understanding the behavior of these submarine giants is crucial, for their fury is not contained by the water that covers them. It is a power that can reach out from the depths to touch the furthest shores. A stark reminder that the ocean's calm surface can be a deceptive mask for the immense geological forces at work below. In the face of such colossal power, humanity is not merely a passive observer. Around the world, a dedicated network of scientists and observatories stands guard, their instruments trained on the planet's most restless mountains. This is the science of volcanology, a field that combines geology, physics and chemistry to decipher the subtle clues that precede an eruption. The goal is not to stop the inevitable, for that is impossible, but to provide precious warning. The time needed to evacuate, to prepare, and to save lives from the oncoming fury of the Earth. The tools of this trade are remarkably sophisticated. Seismometers scattered across the flanks of a volcano listen for the telltale tremors of magma moving far below, a faint, deep rumbling that signals the giant is stirring. GPS stations and satellite radar measure minute changes in the shape of the mountain, detecting the swelling of the ground as the magma chamber inflates like a balloon. Spectrometers analyze the gases escaping from vents, searching for an increase in sulfur dioxide, a key indicator that fresh, gas-rich magma is rising towards the surface, priming the volcano for an eruption. This data flows into volcano observatories in a constant stream where it is analyzed around the clock. Scientists look for patterns, for an acceleration in these signals that might indicate an eruption is imminent. It is a high-stakes detective story, piecing together disparate clues from deep within the Earth to forecast the behavior of one of nature's most complex and powerful systems. The success of this monitoring was demonstrated at Mount Pinatubo in 1991, where timely warnings based on such data led to the evacuation of tens of thousands, saving them from one of the largest eruptions of the 20th century. Yet, for all our technology, prediction is never certain. Every volcano has its own unique personality, its own distinct patterns of behavior. Some provide clear warnings for weeks or months, while others can awaken with terrifying speed. And the greatest threats of all, the supervolcanoes, have not erupted in recorded history, leaving us with no modern template for their behavior. Our vigilance must therefore be constant, our research relentless, and our humility before these forces absolute. We are learning the language of the Earth, one tremor, one gas plume at a time, in a vital effort to coexist with the sleeping giants beneath our feet. Looking to the future, our relationship with volcanoes will continue to be one of profound duality, a source of immense risk and unparalleled opportunity. The threat of a super eruption, however remote, looms as a stark reminder of our planet's capacity for catastrophic change. It forces us to think on a global scale, to consider how our interconnected civilization would cope with a crisis that transcends all borders. Planning for such an eventuality, from securing food supplies to developing strategies for global cooperation, is one of the great challenges of our time, a test of our foresight and our will to survive. Simultaneously, we are becoming ever more adept at harnessing the creative power of volcanoes. And the same geothermal heat that signals danger is also a vast, clean and renewable energy source. In countries like Iceland and Kenya, geothermal power plants tap into this subterranean furnace, providing sustainable energy for homes and industries. As our world seeks to transition away from fossil fuels, the energy radiating from the Earth's molten heart offers a powerful path forward, a way to power our future by working in harmony with the planet's natural processes rather than against them. The study of volcanoes on other worlds, from the towering Olympus Mons on Mars to the cryovolcanoes of Jupiter's moon Io, also expands our understanding of planetary evolution. By observing these alien landscapes, we learn more about the fundamental forces that shape all rocky bodies in the universe, including our own. This cosmic perspective reminds us that volcanism is not unique to Earth. It is a universal process of planetary birth and renewal, a fundamental expression of a world's inner life, whether it erupts with molten rock or frozen nitrogen. Ultimately, our future with volcanoes is a story we are still writing. It is a narrative that demands respect for their destructive power, vigilance in monitoring their stirrings, and ingenuity in harnessing their gifts. They are an intrinsic part of our world's machinery, a force that has shaped our past and will undoubtedly shape our destiny. To live on this planet is to live in the shadow of these giants, to accept their presence not as a curse, but as a fundamental condition of life on a dynamic, breathing, and ever-evolving Earth. For the millions who live in the shadow of an active volcano, survival begins not with an emergency, but with a state of constant awareness. The single most important rule is to respect the zones of risk established by scientists and local authorities. These zones are not arbitrary lines on a map, they are the product of painstaking research into a volcano's past behavior, mapping the likely paths of lava flows, pyroclastic surges, and deadly mud flows known as lahars. To live within a high-risk zone is to accept a permanent and serious threat, a gamble against geological time. Understanding these risks is a personal responsibility. It means knowing if your home, your workplace, or your children's school lies in the path of potential danger. It involves familiarizing yourself with the specific hazards of your local volcano. Is it known for slow-moving lava flows or for fast explosive eruptions? Is the primary threat from ashfall or from the risk of lahars which can travel for tens of kilometers down river valleys, burying everything in their path? This knowledge transforms abstract danger into a tangible reality, forming the foundation of any effective survival plan. Heeding evacuation orders is paramount and non-negotiable. When scientists determine that an eruption is likely or underway and authorities issue a call to leave, there is no time for hesitation or debate. The history of volcanic disasters is tragically filled with stories of those who chose to stay, underestimating the speed and ferocity of the forces about to be unleashed. The Pyroclastic Surge from Mount Pelée in 1902 traveled at hundreds of kilometers per hour, annihilating the city of Saint-Pierre in minutes. There is no outrunning such a force. The only survival strategy is to not be there when it arrives. Therefore, the first and most crucial step in any survival guide is preparation long before the ground begins to shake. It is the mental preparation of accepting the risk, the practical preparation of knowing your evacuation routes, and the communal preparation of trusting the experts whose job it is to keep you safe. Respect for the power of the volcano and the science that monitors it is not a sign of fear, but of wisdom. It is the fundamental principle that allows communities to endure and to survive at the foot of these magnificent but dangerous giants. When an evacuation order is given, time is the most precious commodity, and it must not be wasted searching for essentials. Every household living in a volcanic hazard zone should have a pre-prepared emergency kit, often called a go bag, ready at a moment's notice. This kit is a lifeline, containing the critical supplies needed to survive for several days. It should include non-perishable food and several liters of water per person, a battery-powered or hand-crank radio to receive updates, and a comprehensive first aid kit to treat common injuries. Beyond these basics, the go bag must be tailored to the specific threats of a volcanic eruption. Ashfall can be a major hazard, irritating the lungs and eyes, so high-quality N95 respirator masks and snug-fitting goggles for every family member are absolutely essential. A powerful flashlight with extra batteries is crucial, as heavy ash can create conditions of complete darkness, even in the middle of the day. Sturdy shoes, long-sleeved shirts, and long pants should also be included to protect the skin from falling ash and debris during an evacuation. However, a physical kit is only one part of the equation. Equally vital is a well-rehearsed family emergency plan. This plan must clearly define who will be responsible for grabbing the go bags, who will secure the pets, and what the primary and secondary evacuation routes will be. It is critical to establish a meeting point outside the immediate hazard zone, as well as an out-of-state contact person whom all family members can call to check in, as local communication lines may be overwhelmed or completely disabled during a crisis. This plan must be discussed, written down, and practiced regularly so that in the chaos and fear of a real emergency, every action is instinctual. Where do we meet if we are separated? What is the route if our primary road is blocked? Who is our point of contact? Answering these questions in the calm of an ordinary day is what saves lives in the pandemonium of a disaster. The go bag and the family plan are not just items and ideas, they are a declaration of preparedness, a commitment to taking proactive control in a situation that can feel utterly overwhelming.
Perfect.
If an evacuation is not possible or you are caught unexpectedly by an eruption, the most widespread and immediate hazard is often volcanic ash. This is not the soft, fluffy soot from a wood fire. It is a harsh, abrasive material made of pulverized rock, minerals, and volcanic glass. When it falls, it can blanket entire landscapes in a thick, heavy layer, posing a multitude of dangers. The first priority during an ashfall event is to seek shelter indoors immediately and stay there until authorities declare it is safe to come out. Once inside, all doors, windows, and ventilation openings must be sealed as tightly as possible. Use damp towels to block the gaps under doors and tape over any cracks to prevent the fine penetrating dust from entering your home. Turn off all heating and air conditioning systems that draw air from the outside. The weight of heavy wet ash can be immense, posing a serious risk of roof collapse, especially on flat or low-pitched roofs. If you're in a single-story building and the ashfall is severe, be prepared to move to a stronger part of the house and listen for any creaking or groaning sounds that might signal structural distress. Protecting your respiratory system is critical. If you must go outside, even for a moment, wear an effective dust mask like an N95 respirator and protect your eyes with goggles. The sharp, glassy particles in ash can cause severe lung damage, a condition known as silicosis, and can scratch the cornea of the eye. If you do not have a mask, a damp cloth held over your nose and mouth can provide some limited temporary protection. Every effort must be made to avoid inhaling the ash, as its effects can be debilitating and long-lasting. Conserving clean water is also essential. Ash can contaminate open water sources like reservoirs and wells, and water treatment facilities may be overwhelmed or shut down. Before the ash arrives, if possible, fill bathtubs, sinks, and any available clean containers with water. This stored water will be your lifeline for drinking, sanitation, and cleaning. Surviving the ashfall is a test of patience and resourcefulness, a matter of sealing yourself off from the outside world and waiting for the sky to clear, armed with the knowledge and supplies to endure the grey twilight. The end of an eruption does not signal the end of the danger. The aftermath presents a new set of challenges that can persist for months or even years. The landscape is now transformed, often covered in a thick blanket of ash that has contaminated water supplies, destroyed crops, and disrupted every facet of daily life. The journey to recovery is a long and arduous one, beginning with the careful and systematic process of cleaning up. Ash must be removed from roofs to prevent collapse and cleared from roads to re-establish transportation links. This cleanup process is fraught with its own risks. The fine ash can be easily stirred up by wind or activity, creating a persistent air quality hazard. It can clog machinery and damage electronics, and when mixed with even small amounts of rainfall, it can form a concrete-like sludge that is incredibly difficult to remove. Furthermore, the ash can transform into a secondary and equally deadly threat. Heavy rains falling on the thick deposits of loose ash on the volcano's slopes can trigger devastating mudflows or lahars long after the eruption has ceased, sweeping down valleys with the force of flowing concrete. The psychological toll on communities is also immense. Survivors must cope with the loss of homes, livelihoods, and sometimes loved ones. The familiar landscape may be rendered alien and hostile, a constant reminder of the trauma they have endured. Rebuilding a community is not just about reconstructing buildings and infrastructure. It is about restoring a sense of safety, hope, and normalcy. This requires strong community bonds, government support, and long-term mental health resources to help people process the event and adapt to their new reality. Yet, through this process of recovery, a remarkable resilience often emerges. People work together, clearing streets, checking on neighbors, and sharing resources. In time, the very ash that brought such destruction will break down, enriching the soil and paving the way for a new generation of life and agriculture. The aftermath of an eruption is a testament to both the destructive power of nature and the enduring spirit of human communities. Their ability to not only survive, but to rebuild and find a way to thrive once more in the shadow of the volcano. We have journeyed deep into the Earth's fiery heart, witnessed its awesome power to both create and destroy, and learned of the courage and ingenuity of those who live in its shadow. The story of volcanoes is the story of our planet itself, a world of constant change, of immense power, and of profound interconnected beauty. It is a reminder that we are part of a system far greater and more ancient than ourselves, a system that demands our respect, our curiosity, and our vigilance. The sleeping giants are a part of our world, and we must learn to live with them. The knowledge we've shared is not just for those who live near a volcano, it is for everyone who calls this dynamic planet home. Understanding these fundamental forces helps us appreciate the world we live in and the challenges we may face together in the future. It is a story of science, of history, and of human resilience. If you have found this journey as awe-inspiring as we have, help us share this knowledge. The more people who understand the power and the promise of our planet, the better prepared we will be to face its challenges together. We urge you to share this video with your friends, your family, and your community. Spark a conversation about the forces that shape our world. Subscribe to our channel and join us as we continue to explore the most incredible phenomena of our universe. From the deepest oceans to the furthest stars, your support allows us to continue bringing these vital stories to light, to foster a deeper understanding and appreciation for the world we all share. There is always more to learn, more to discover, and more to be amazed by. So let this be our final message. Reflect on the power you have witnessed. Consider the delicate balance between the forces of nature and the persistence of life. The Earth does not operate on a human timescale. Its rhythms are deep, powerful, and relentless. It is a world of sleeping giants and hidden fires, a place of constant transformation. We must remain curious, we must remain prepared, and we must remember, nature does not wait. Our journey through the world of fire and rock comes to a close. We have seen the Earth tear itself open, birthing new land from its molten core. We have walked through the ghostly remains of cities frozen in time by ash and stood in awe of the resilience of life that always returns, finding purchase in the fertile soil left in destruction's wake. The volcano is a paradox, a symbol of nature's terrifying, untamable power, and at the same time a fundamental source of the renewal and richness that allows life to flourish across our planet. The stories of Vesuvius and Tambora are not just historical footnotes, they are potent warnings etched into the geological memory of our world. The silent, swelling ground at Yellowstone and the hidden fury of the mid-Atlantic ridge are not distant, abstract threats, but active processes that shape our present and will define our future. These are not monsters to be feared, but fundamental components of our living world whose language of tremors and steam we are only just beginning to truly understand, a language we must learn for our own survival. The power to survive and even thrive in this dynamic world lies in knowledge, preparation, and a deep, abiding respect for the forces at play. It lies in the work of scientists who listen to the Earth's heartbeat, in the wisdom of communities who create plans and practice drills, and in the individual responsibility of every person to understand the world they inhabit. The volcano teaches us our most important lesson, that we are not masters of this planet, but inhabitants, privileged to witness its spectacular and sometimes violent majesty. Thank you for joining us on this exploration of the sleeping giants beneath our feet. The story of Earth is one of endless fascination, and we have only scratched the surface. There are countless more wonders to uncover, more mysteries to solve, and more stories to tell about our incredible home. So we ask you now to continue the conversation. Share this video, subscribe for more, and remember, nature does not